let's take a quick minute and talk about the vertex form of a quadratic function. When we worked on one of our last set of problems, this was the answer to one of those practice problems. You were given this function, y equals x minus 3 squared plus 1, and your goal was to fill out the table and then to go ahead and graph it. And if you did that correctly, this is what you get. Now you'll notice your table ended up, just like before, being symmetrical, and you did create a graph that was also symmetrical. We had our axis of symmetry and our minimum, which gave us a vertex right down here at the point 3, 1. Now, if you do this a few times, you'll start to notice a few things, and hopefully you did notice a couple of similarities. Namely, that our vertex 3, 1 had some similarities to our initial function. That is, the number 3 and the value 1 were both in our original function when it was in this kind of oddball format. You know, if you remember right, we're kind of used to seeing our functions be y equals ax squared plus bx plus c. Well, if you look at this one, it's in a slightly different format. Instead of ax squared plus bx plus c, this one is y equals a times x minus h, which is a new variable, squared, plus k, which is another new variable for us. And this is something that's called vertex form. And the reason for that is because in this format, it tells us where the vertex of our parabola is just by looking at the function itself. So let's take a look at how that works. So here's the first of our practice functions. We're given this function, f of x equals negative 1/2 times x minus 1 plus 2. If we look at our graph, we can find immediately that our vertex is right here at the point 1, 2. Now let's compare that to our previous problem. Bring this out of the way, and in drops our original function. Now if you recall, this original function had a vertex of 3, 1 and was located right there. Now if you look at these and compare them, you'll notice that our y value for both of our vertexes is found at the end of both of our functions. When we talked about that generic formula, which if you recall was this y equals a times x minus h squared plus k, means that these values out here must be our k value. Next, if you look, you hopefully noticed that our x values for both of our vertices was the number inside the parentheses with one little difference. Where the value in our vertex was, in this case, positive 1, the value in the parentheses was negative 1. And the same thing happened in our other problem. Our vertex had an x value of positive 3, and our function had an x value of negative 3. They were opposites. Now what this means is that we can use our vertex form to find our vertex really easily. So let's look at that vertex formula again. Here we go. Y equals a times x minus h squared plus k. Now, we just said a second ago that our k value here is the y coordinate of our vertex. And we said that this value, our h value, was the x value, except it was opposite. That is, if it was a positive 3 in our formula, our vertex was actually negative 3. So how do you turn, say, a positive 3 into a negative 3? Well, the easiest way is simply to multiply it. In this case, if you take a positive 3 and you multiply it by negative 1, you get negative 3. So what if we were to build a formula? And maybe that formula would be something like this, that our vertex would be equal to the point negative h, comma, k. That is, it's equal to negative 1 times whatever the value of h is and the point k. So the real question becomes, how can we use that? Let's take a look at these examples. We have 3 graphs in this case. Number 1, in blue, we have just y equals x squared. That's our standard parent function for a quadratic, just y equals x squared. And now we've got these other 2 graphs. While we're given both the graphs and a scale, and we're given the equations, it's not super easy to see exactly where the vertexes are. But knowing vertex form, we can find them. So let's do that. So our first equation, the one that we'll deal with in pink, right here, says that our vertex has a value somehow related to x plus 5 and positive 1. So our h value is positive 5. Our k value is positive 1. Since we know that our vertex is negative h, comma k, we know that it's negative 1 times positive 5, comma k. And in this case, k is 1. So negative 1 times 5 gives us negative 5, and our k value is 1. So we know that this point, right at our vertex, has to be negative 5 equal 1. If we look at our red parabola, related to the equation x minus 3 squared minus 4, we can see that our h value is negative 3, our k value is negative 4. So, since our equation is negative h, comma, k, then we know that our vertex would have to be negative 1 times negative 3, comma, negative 4. We should be able to know that negative 1 times negative 3 is positive 3, and our negative 4 won't change. When we look back at our graph, we should be able to see that the point 3, negative 4 is exactly where our vertex is. Now, we've found our vertexes from equations, but what about the opposite way? What if we're given an equation and we need to graph it? Well, vertex form gives us a great way to figure out where to start. Let's say we're given this equation here at the top. That is x plus 1 squared minus 2. From our formula, where we talk about negative h, comma, k, we know our vertex has to be at the point negative 1, comma, negative 2. So we can immediately jump into our graph and go ahead and line out our vertex at negative 1, negative 2. From this point, it would simply be a matter of filling in our t-chart. And if we go ahead and do that, that allows us to find several more points. From that, we would find that we would get the points 0, negative 1, and 1, 2. Since we know that there's an axis of symmetry right along the vertex, we can duplicate these points as well and get the point negative 2, negative 1, and negative 3, 2. From there, it's a simple matter to draw our curve and get a rough sketch of our parabola. Let's do it one more time. This time, let's look at the equation negative x minus 2 squared plus 2. So once again, let's start by finding our vertex. Our h value is -2. Our k value is +2. So from this, we can build ourselves an actual vertex. And our vertex, according to our formula, would be +2, +2, or the point 2, 2. So we'll go ahead and we'll mark that point. So there's our vertex. If we keep finding more points, we can line out a few more spaces on our graph. So if we keep plugging in values, we can find the points 1, 1, and 0, -2. Once again, our axis of symmetry tells us there are matching points on the opposite side of our vertex. And from here out, we can again use these 5 points to draw our rough curve. So that's another way that we can use our law for finding the vertex form, or using the vertex form to find our vertex, to turn an equation into a graph real fast and simple. And we'll explore this further in the future, as well as finding mathematical ways to find our vertex and our axis of symmetry when it's in standard form instead of vertex form.